Hi, welcome to the definition of the derivative, day 2. Now in day 1, we learned the actual definition of a derivative. It was that limit process, right? The limit as h goes to 0 of f of x plus h minus f of x all over h. And the one thing we learned the most of, this is a nice formula, but it is very, very lengthy to do the process, especially if we're just looking for a slope. Remember, this is just a slope finder. It is not actually the slope itself. If I want to find the slope of a function, we would have to find our derivative and then plug it back and plug our x value back in. Now the derivative is used to help calculate the value of a slope at any function at any point. However, this derivative rule is very tedious. Therefore, if we want to find just the slope, if we just want to find the slope, we can use what we call the alternate form of the derivative. And this is what it looks like. Again, you're looking at that f prime of c. And we might remember yesterday, f prime of x is the derivative, but if we did f prime of c, we called that the actual slope itself, and you always get a number when you do that. So this is our derivative. This is actually the slope itself, and it's a little similar but different. It is the function minus the value at c over x minus c. Now if you notice though, we do get 0 over 0, which is why we take a limit. So we're going to let x approach the value we are looking for, where we say c is the x value we want the slope at, and f prime of c is the slope itself. So let's see how this works. Use the alternate form of the derivative to find the slope of this function, this parabola, at x equals 3. Well, to get the slope, that's going to be saying f prime of 3. And my rule says take the limit as x approaches 3 of f of x, which is this x squared minus 4x minus the value at 3. And I'm going to go and do that. This becomes 9 minus 12, right? Remember, this is the value, the actual value at 3, f of 3, over x minus 3. Now, I'm going to go ahead and simplify that on top here, and most of us should be pretty good. This becomes x squared minus 4x, and of course this becomes plus 3 over x minus 3. Right away you should notice, if I plug in 3, I get 0 over 0, which is a no-no. So I'm going to factor the top. And the top, of course, becomes x minus 3, x minus 1, over x minus 3. Oh, look, those cancel, because again, anytime you have 0 over 0, something's going to cancel. And now I can just substitute in. I get 3 minus 1, which is 2. So therefore, I can say the actual slope at x equals 3 is 2. Now, be careful. One thing to remember, this is not the derivative. The derivative is a function in terms of x. This is the, I can't spell derivative. There we go. This is the actual derivative. This is not the derivative, sorry. This is the actual slope itself. And what it does, it kind of takes out the middleman. Remember from yesterday when we found the derivative, we would get a function in terms of x. And then we would have to plug in 3. This is a little bit shorter if you're only looking for a slope. Now, what about linear functions? Kind of a trick question. Again, linear functions, the slope is always 2, right? Remember that? The slope is constant. So let's take a look at a few more examples. Oh, here's a tricky one. What if I give you something like f of x equals 5? What's the slope here? At any given point, it's going to be 0, right? Because that's our horizontal line. So let's practice some. We want to, now there's going to take a look here. In step A, we want to use the definition of the derivative to compute the slope at 1. Then we're going to use the alternate form to compute the same slope. Find out which is easier. So remember, we got our definition. We get f prime of x is the limit as h goes to 0 of 3 times x plus h squared minus 7, f of x plus h minus the original function 3x squared minus 7 over h. If I simplify this, we get the limit as h goes to 0. Now, this is my easy one. This is just x squared plus 2xh plus h squared, but again multiplied by 3. So we get 3x squared plus 6xh plus 3h squared minus 7 minus 3x squared plus 7 all over h. And of course, everything that does not have an h cancels, and I can factor out my h here. So I get the limit as h goes to 0. Factor out the h, 6x plus 3h over h. Those cancel away, and we're left with a derivative equaling 6x. Now remember, this is the derivative. Now we got to get the slope at x equals 1, because that's what this is looking for, right? The slope. And we would get f prime of 1 equals 6 times 1, which is 6. So there's the slope right there. All right, now let's take a look at the same formula, but this time let's use the alternate form. And watch what happens. When we take f prime of 1, my alternate form says this just becomes the limit as x approaches c, which in this case is 1. And this has become f of x. Remember my rule up here. There it is, f of x, the original function, 3x squared minus 7 minus the value at 1. And I can do this, 3 minus 7 over x minus c, which is 1. Be careful, don't do x minus 8, it's x minus 1, because there's my c value. And if I clean this up a little bit, this becomes 3x squared minus a negative, or 3x squared minus 7 minus a negative 4, which becomes 3x squared minus 3 over x minus 1. And again, this does become 0 over 0. So I'm going to factor the top. I can factor out a 3, and I get x plus 1, x minus 1, all over x minus 1. Those cancel, and if I plug in the 1, we do get 3 times 2, which is 6. Either way is okay to use, but if you're just looking for a slope, the alternate form is much quicker for us. So let's try for question number 2. Use the definition of the derivative to compute f prime of 4. So now this one you had on your homework last night. I didn't teach it to you, but let's see what we're going to do here. So we take the limit, so f prime of x, we get the limit as h goes to 0, square root of x plus h minus the original function all over h. And hopefully you guys kind of figured out we have to use conjugates for this one. Same on the bottom. Now eventually you're going to be able to do this one in your head. But right now let's just take a look at what we get here. Don't forget your limit, very important for us. Distributing, we get x plus h minus x over h times the square root of x plus h plus root x. And if you notice, now this is going to be really tricky, the x's cancel, but what else cancels? I'm just left with these two h's. Those cancel. So we're left with the limit as h goes to 0 of 1 over the square root of x plus h plus the square root of x. And if we let h go to 0, we get 1 over 2 root x. And that's our derivative. Woo-wee! Look how long that took us. So to get the slope now, again, that's what they're asking for. The slope is f prime of 4. I would do 1 over 2 times root 4, which is just 1/4 for us. And there's the slope. Again, a very tedious process. So for part B, let's take a look. Use the alternate form of the derivative to compute f prime of 4. Let's just take a look at part B. Use the alternate form now. This is now saying f prime of 4. Remember, this is actually my slope itself. And this says take the limit as x approaches 4, f of x, which is the square root of x, minus the square root of 4, right? Because remember, there's f of c right there, right? That's f of c right there, over x minus 4. And if I simplify this, I get the limit as x approaches 4, the square root of x minus 2 over x minus 4. So again, how do I solve this? We're going to use the conjugate, although if you really want to be fancy, I can actually factor the top as a difference of squares. This is kind of fancy math. You can use the conjugate here, you'll get the same answer, but watch what happens. This is just, not factor the numerator, I can factor the denominator as the square root of x plus 2 times the square root of x minus 2. Just something really fancy for us. And that becomes a 1 up there. And if I plug in the 4, I get 1 over root 4 plus 2, or 1/4. A real quick way to do that. All right, so that's part 1. So go to part 2 and take a look at a few more examples with the rational as well. It'll help you from your homework.